we are going to continue talking about circles. Right now we're going to focus on tangents first, and then we're going to talk about arcs and angles. So remember, tangent from your vocabulary means a line that intersects the circle at one point. And here we're given what's called the two-tangent theorem, which says that two tangent segments drawn to a circle from the same external point are congruent. So if we look at this practice problem here, I'm told that AB and AC are tangent to circle O. And they both are tangent from this external point A. They share external point A. So that tells me that these two segments are going to be congruent. And I'm given this expression for their lengths. And then if OC is 5x, I want to find the length of OC, or the radius of my circle O. So because we have this two-tangent theorem, I know that AC and AB are congruent segments. So to find x, I can just set these two expressions equal to each other. So I can set 14 plus 4x equal to 19 minus 6x. And now I'm just going to do a little bit of algebra. I'm going to move all my variables to the same side. And then I want to move all my constants to the same side. And I end up with 10x equals 5. So I do my last step of dividing. And x is equal to 5 over 10, which is 1/2. So if x is equal to 1/2, remember, I still want to find OC. And OC is equal to 5x. Well, x is 1/2. So that's going to be 5 times 1/2. So OC is equal to 5 over 2. So nothing too bad there, really. But let's take a look at now our angles and how they are related to our arcs. So we have a couple theorems here, but they can really be summarized with the statements in this box here. So talking about angles, if the vertex of an angle is at the center of a circle, then its angle measure is equal to the arc that it intercepts. If the vertex is inside the circle but not at the center, then its angle measure is half the sum of the two arcs that it intercepts. If the vertex is on the circle, so on the edge, then it is half the measure of the arc that it intercepts. And lastly, if the vertex is outside the circle, then it's half the difference of the two arcs that it intercepts. And that sounds kind of tricky, but we'll take a look at a couple practice problems and it shouldn't be too bad. So starting with number 1, we're given that FE is tangent to E and the measure of arc DE is 80, and I want to find the measure of angle DEF. So let's start by locating our vertex. Our vertex for angle DEF is E, and it is on our circle. So let's go back to our summary box. And right here, when our vertex is on the circle, the measure is half the arc. So here my arc is 80. So then the measure of angle DEF is going to be 1/2 of 80, which is 40. So the measure of angle DEF is 40. All right, looking at number 2, I want to find the measure of angle A. Well, A's vertex, where is it? It is outside the circle. So if we look at our summary box here, when the vertex is outside the circle, it is half the difference of the two arcs it intercepts. And if we look at this diagram we're given for number 2, it shows the measure of the two arcs it intercepts. One of them is 100, the other one is 20. So the measure of angle A is going to be 1/2 the difference of 120. So that means 100 minus 20. Well, 100 minus 20 is 80, and 1/2 of 80 is 40. So the measure of angle A is also 40. All right, let's do one more. Looking at number 4, we want to find the measure of angle O. Well, let's look at where angle O's vertex is, and it is at the center of our circle. So let's go back to our summary box. When the vertex is at the center, they are equal. So this one is equal. So angle O is equal to the measure of arc AB, which is 62 degrees.